radiation as it's moving through our atmosphere. And there's a couple terms you'll see in your list of terms and objectives, and that is solar constant, which is former way it was referred to. Today, they are more likely to use TSI, or total solar irradiance. And what that refers to is the amount of solar radiation that reaches our atmosphere from the sun. Now, that's not what reaches the surface of our Earth, though, because as the solar radiation, that TSI or solar constant, enters our atmosphere, various things happen to the wavelengths of the solar radiation, such that only about half reaches the surface. So let's look at that. What is in our atmosphere? First of all, when we were going over the Earth systems, we talked about the lithosphere, the biosphere, the hydrosphere, and the atmosphere. And the definition of the atmosphere was just the blanket of gases that surround the Earth. So what are those gases? Turns out that 3 of those gases make up 99% of the gases in the atmosphere. So let's go ahead. I want you guys to memorize actually the percentages of the top 3 gases in Earth's atmosphere. I'm going to zoom in here and you can see the image. This is a pie chart showing you, 2 of them. It doesn't really tell you about the third one yet. So from the pie chart, you can see nitrogen is actually 78% of the gases in our atmosphere. 78%. So obviously huge. And these are rounded. I'm rounding them to a whole percent. They're not exactly that. The next most abundant gas in our atmosphere is oxygen at 21%. Okay, so nitrogen and oxygen, O2 and N2. That means that there's 2 oxygen atoms making an oxygen molecule, O2, and 2 nitrogen atoms making a nitrogen molecule, N2. So as you can see, together, that's 99%. Now, the pie chart is showing inactive gases. Well, it turns out that the third most abundant gas in our atmosphere is one of these inactive gases, and that is argon. Spell it out, argon. And that is at 0.9%. So the 3 of these together is 99.9% of all of the gases in our atmosphere. That's huge. What are some other gases that you're familiar with? Ones that are talked about in the news, for example. All of these other gases that make up less than 0.1% of Earth's atmosphere are referred to as trace gases. That means that they're such a small amount. Trace gases. Now, I want you to know one of these gases, one of the most abundant following these 3 that we're talking about, and that is carbon dioxide. So you've probably heard of carbon dioxide. We breathe in oxygen, we breathe out carbon dioxide. Plants, on the other hand, take in carbon dioxide to create energy and carbohydrates, and they release oxygen. So carbon dioxide, big deal, right? It's part of the carbohydrates, the building blocks, the carbon, basically, of life. Also, you may have heard of it as a greenhouse gas and the main anthropogenic cause of climate change. We haven't talked about anthropogenic yet. Let me talk about that word, anthropogenic. Okay, at College of Marin, the geography lab shares a lab with anthropology. Anthropology. What is the anthropo for? Very good. It's humans. And then this genic, okay, we're going to hear that quite a lot in science. It means created by. Like if you think of the book of Genesis in the Bible, Genesis, creation, created by humans. So if you talk about anthropogenic climate change, you're referring to climate change that is created by humans versus other factors that could contribute to climate change. All right, so CO2, it's a natural gas in our atmosphere. It's a very important gas. It's not a bad gas. That sounds funny. The only thing that's bad about it is that we are putting a lot more carbon dioxide into the atmosphere than is part of the natural fluctuation in carbon dioxide. So we're going to talk about greenhouse gases, not in this lecture video, but in one coming up soon. So since I've been teaching this, since I took this class and since I've been teaching it, the amount of carbon dioxide has been increasing, and I have to keep changing the amount that I give. Well, I'm going to kind of simplify that. I'm only going to give it to a 100th of a percent. And that sounds, man, that's like really small. Here we go. CO2, carbon dioxide, 0.04%. Okay, so it was 0.03% before when I was teaching him. 0.036, 37, 38, 39. Then came 4, 4.1, 4.2, 4.3. Yeah, you get the picture. All right, so all I want you to know, though, that and as far as what I'll be testing you, is 0.04 for carbon dioxide. That's a number that keeps increasing. The probably most common way that you hear about carbon dioxide being mentioned is parts per million. So that's a ppm, whereas this is a percent. So it would be a greater than 400 parts per million. Okay. Let's see. And then finally, another really abundant gas in our atmosphere that you should know, but it's extremely variable, is water. So you should know that water comes in 3 forms or 3 phases or 3 states. Those all mean the same thing. That is gas, which is what we're talking about, liquid, and solid. So what I'm talking about in the atmosphere is the amount of gas. And that gas varies. So if you think about humidity, you know that humidity really varies across the earth, depending on location. Where it's really dry, like in the Arctic zones, Antarctic and Arctic zones, it would be less than 1% of the atmospheric composition. By the way, this percentage here is of the dry atmosphere. It means that they don't even take into account water. This is a dry atmosphere because water is so variable. So they take that out, and then in some of the most humid parts, like think of the tropics where there's a lot of warm water evaporating into the air, it can be as high as between 3 and 4%. So it's really variable. You should know that. So they often give like an average of about 2% of the atmosphere as water gases. Okay, so we've got all of these gases in our atmosphere and a lot of other trace gases that I'm not mentioning here. And the solar radiation interacts with these gases. So let's go ahead and draw the sun. It's kind of a greenish sun. And we have the Earth. And do you remember, for the sun, would you expect shortwave radiation or longwave radiation, depending on its temperature? It's hot, shortwave or longwave. There's a whole slew of wavelengths that come from the sun, but because of its temperature, it's referred to as shortwave radiation. The biggest bulk of its radiation is shortwave radiation. So we can go ahead and I'm going to just draw this in to kind of visualize shortwave radiation coming in from the sun. What about the Earth? What does the Earth emit in terms of radiation? It's much cooler than the sun. Shortwave or longwave? Very good. Long wave radiation.